So the purpose of this lab is to first find the mass of the black hole from the given information. Then with the mass of the black hole found from part 1, the students will have to find the initial speed of the spaceship should be in order to not to crash into a black hole. And the main principles used were the Newton's second law, which states that the acceleration of an object is directly related to the net force, and is inversely related to its mass, and the gravitational force, which is saying that the larger the mass, the greater the force, and the momentum principle, which describes how a system changes its motion when it experiences a net force, and the equations used were to find the momentum, P equals mv, the gravitational force, and the F net is equal to F net parallel plus F net perpendicular, and another main equation that was used were that dp over dt, the delta p over delta t parallel is equal to this equation, which we'll discuss further into codings. And to find the mass of the black hole, the initial condition was to our mass is equal to 2 to the e 30 kilograms, and system was the star and black hole because the black hole was acting on the stars and the gravitational force of the black hole was acting on the stars, and this was the results, and as the results outputted a bunch of masses from each of the positions, and I just had to take the average of that to find the mass of the black hole. So to find this mass of the black hole, I had to edit the initial masses of the star and the initial delta t, and then the main ones here that were more F net is equal to dp dt, and to find the dp over dt parallel, I had to use the formula given here. Dp over dt parallel is equal to magnitude of p final minus magnitude of p initial over delta t. And then to find the dp dt perpendicular, I just subtracted the dp dt minus dp dt parallel to find the dp dt perpendicular, because if we rearrange the equation, dp dt perpendicular plus dp dt parallel is equal to dp dt. And then to find the mass of the black hole, basically the gravitational force equation, the gm1 m2 divided by r squared, magnitude of r squared times r hat was equal to the F net, and I just isolated the M2, which is the mass of black hole, and then this was the equation that printed out all the list of the mass of the black hole. And for part 2, the initial condition that we found from part 1 was that 1.49 to the 34 kilograms, and the system was the spaceship, and the surrounding was the black hole and planet because they were imposing a force on the spaceship. And basically this was the edited line, the initial value, this is what we had to change, the speeds, and this was more of a trial and error. And this was to find the R vector, I had to subtract the positions and then plug that all into the gravitational forces formula that was discussed earlier, and adding how the black hole and the ship both had on the planet the force effect. I just added the two forces and then found the final force, and it's basically the same with the ship. I added the force of black hole and the force of planet on the ship and added them together, and then this was basically where Newton's second law really played in on the velocity update formula and the position update formula, and the same with the ship and the planet. And getting all that, I inputted values, it made sure it was negative, the ship speed was negative x because it was going towards the black hole, and then so the possible error is that it didn't make a full loop, and one of the reasons could have been that the velocity was too high, or maybe that the velocity of the x and the velocity of y was too far apart, which is why it didn't make a full loop. It still did get out of the ship did get out of the planet, the black hole, so it was a success, but that could have been a possible error that could have helped make a more full loop. And so for what does it mean and what if, so the discussion of the rate of momentum and what net force. So the difference between the two is that mathematically they're similar because F net is equal to dp dt. However, F net is the net force acting on the object, so it is measurable, where dp dt is how the momentum of the object is changing. And for the what if, how to enter an orbit around the black hole or full orbit. So in order to have like a full orbit around the black hole, the x and y component of the initial velocity could have been more relatively similar, and instead of and not extremely fast to the point it is like extremely near the speed of light, and that could have helped make a full orbit.